Hey everyone! If you're enjoying this content, don't forget to hit that subscribe button and follow us on Facebook. Your support means the world to us, and it helps us continue creating great content for you. In this video, we will learn on how to run the state-of-the-art yolov10 object detection. First, we need to install all the necessary package and isolate our yolov10. To avoid conflict on our other projects, open your terminal and type sudo apt install python 3 virtual env and hit enter. Now type your password and hit enter. If you are on Windows, just type pip3 install virtual env. Next we will create an environment for our yolov10 project. For you to grab the idea, we will be creating a folder named yolov10env. As our isolated environment, let's open the home file folder. With that, you can't see a folder named yolov10env. The same as looking files on the terminal. Open your terminal, type ls and hit enter. We also don't see a folder named yolov10env. Now let's create that folder. On the terminal, type virtual env yolov10env and hit enter. Let's check it. If the file is successfully created, type ls. As you can see, yolov10env now exists. Let's take a look inside of that folder so that we can grab a deeper knowledge on how to activate it. Let's open the file folder and click the yolov10env. Then click bin folder. This is the environment activation file that we must call. It's inside the bin folder. With that, let's proceed. Open your terminal and type source yolov10env bin activate and hit enter. To activate our isolated yolov10 environment, environment is successfully activated when you see this. All package installation via pip will only be installed on this environment. To deactivate environment, just type deactivate and hit enter. Let's activate it again and start to install the required packages. Install torch. Type pip3 install torch and hit enter. Install torch vision. Install Onyx. Install Onyx Runtime. Install PyCoco tools. Install PyYAML. Install SciPy. Install Onyx Sim. Install Onyx Runtime GPU. Install psutil. Install PyCPU info. Install Hugging Face Hub. Install Safe Tensors. Install OpenCV Python. Install Pandas. We have already installed the required packages needed for yolov10. Let's now go to yolov10 GitHub page and download it there. Go to this GitHub page. Then download the zip folder. When the download finish, navigate to download folder. Right-click the downloaded yolov10 main.zip, and click Extract. After that, we will download a pre-trained model yolov10n.pt in my GitHub page. Go to this GitHub Glenn Ford 49, yolov10 model. Next click the yolov10.pt and click Download. Also, click the overhead.mp4 and click Download. When the download finish, navigate again to Downloads folder and drag the downloaded model and video file to the yolov10 main folder. After that, open a new tab in your VS Code editor. Then drag the extracted yolov10 folder in your VS Code editor. Next, we will create a new file and name it yolov10 detect.py and hit enter. We need to import some libraries. Import the OpenCV library, CV2, which is used for video capture and image processing. Import the time library, which is used to measure the time taken for each frame to process, helping calculate the frames per second, FPS. Import the yolov10 model class from the Ultralytics library, which is used for object detection. Now let's define a function named yolov10 inference which takes 4 parameters: frame, model, image_size, and confidence threshold. Then, we will define variable result to the detected objects. Also, we will declare frame variable which plots the detection results on the frame. Finally, we will return the annotated frame. Now let's define the main function. First, we will define the image size. Let's just use 640. Then, we will use a confidence threshold value for detection. Let's just use 0.25. Next, we will load a pre-trained yolov10 model. Next, we will define a variable source of our video or camera. We will also create a cap variable for our video capture object that opens from the specified source. This line checks if the video capture has been successfully opened. This line prints an error message if the capture could not be opened. Then, exits the function if the capture could not be opened. Now, we will start an infinite loop to continuously process video frames. This line reads a frame from the video capture object. Ret is a boolean, indicating if the frame was read successfully, and frame is the image data. We will use start time to record the start time before processing the frame. This line checks if the frame was not read successfully. Exits the loop if the frame was not read successfully. We will now call the inference function to process the frame, and assign it to a variable frame. Then, an end time to record the end time after processing the frame. Calculates the frames per second, FPS, based on the time taken to process the frame. Formats the FPS value as a string. Draws a black rectangle on the upper right corner of the frame to display the FPS. Puts the FPS text inside the black rectangle of the frame. Displays the annotated frame in a window. Checks if the Q key is pressed to exit the loop. Exits the loop if the Q key is pressed. Releases the video capture object. Closes all open CV windows. Finally, we will call the main function to start the process. This code captures video from a specified source, processes each frame using a yolov10 model for object detection, and displays the results in real time along with the FPS.